preparing to live stream. We are now streaming live with a short delay. Should we admit their AI note along with them? Or maybe it's someone else. All right, I'm going to start it. I'm going to admit the people that are in the waiting room. Good afternoon, everyone. We will be able to provide a recording of this meeting. It's also streaming live, so we'll be up on YouTube right after the meeting. Looks like Matt. Okay. We will go ahead and get started because we know that you're, as I admit this last person in, last two people in. I'll continue to monitor everyone who's coming into the waiting room, but we will go ahead and get started since your time is precious and we appreciate you spending your time with us today on Thursday. So welcome to Q-PAC's Fan Architecture Seminar or Webinar, I apologize. Today, Salem Homrighausen is going to be presenting. Salem is an engineer with Q-PAC. He has his bachelor's and his master's from the University of North Florida. We're excited to have him presenting today on the multi-motor plenum fan architecture category, as well as Q-PAC fan. We will be moving through that. Just a couple of housekeeping things at the beginning. My name is Eddie. I'll be your MC. Feel free to direct any thoughts or ideas into the chat. We will save them for the Q&A at the end. You will also be able to come off of mute and be able to ask your questions directly. So we'll be monitoring the chat. We will have that time at the end, and we really hope to find this an engaging presentation for you. So without further ado, we will go right into the presentation. I'll let Salem take over.
Awesome. Thank you, Eddie. First thing, can everybody see my screen? Should say Q-PAC NPF Architecture Webinar. You guys see everything? Okay, great.
Yeah.
All right. Well, my name is Salem Homrighausen. I'm a field marketing engineer at Q-PAC. I've been here about 3.5 years. I was in the power industry before that, working as an electrical design engineer. And then I moved over to the marketing and sales side at Q-PAC and haven't looked back. So, I have a master's degree in electrical engineering from the University of North Florida, like Eddie said, and I'm primarily responsible for building awareness and educating about the Q-PAC product. So without further ado, I'll just get into the heart of it here. All right, so as you can see, these two fans here, the one on the left is your traditional housed squirrel cage blower with a kind of shiv and belt and motor system here for actually providing airflow to the space. So this is your traditional blower system, and it's what people used for decades. It's what most people are familiar with, and it was something that everyone learned how to maintain, and it's a simple to maintain product, although it does have its limitations. Around the shortly, once this product started to be phased out a bit, or you start to see less of them, these just kind of single plenum fans over here on the right were kind of what replaced them. So the idea was with these designs, you're going to have one single fan that's going to supply air for a space, and the idea being that you're going to get the most mechanical efficiency out of a single large impeller that's going to provide all the airflow for the space. So that was kind of the primary design philosophy around these products. And the plenum fan here on the right replaced in general the house fan on the left. We can get into specifics of why it went like that, but for our purposes, just I want to show you the progression of the technology over time. Shortly after, I think it was in the 90s was when this product first came around, uh, the direct drive plenum fan array became a solution for airflow for buildings. And a lot of times it's going to be applied in those critical spaces where it's unacceptable to lose a motor or lose a single blower for airflow for the space for any reason, right? So these are places like hospitals, data centers, manufacturing facilities, anywhere where no airflow means your operation is not operating, right? So this picture here is really kind of showing that design of those direct drive plenum fans in an enclosure. Excuse me, each one of it is in its own enclosure. And this was likely either, if it was in a new air handling unit, it was probably installed in the factory. If it was a retrofit option, then it was something that was actually done in the field. And as a result, it probably required a lot more coordination. And that's something we're going to get into here in a little bit. But this is your direct drive plenum fan array. And shortly after this product was launched, the ECM fan array became a more dominant version of this. And what I want to explain is how Q-PAC developed the multi-motor plenum fan as kind of the next step in the evolution of the fan array, right? The idea being that, you know, if you have enough pieces to the fan array, if you've consolidated all of that scope of the ECM plug fans, the harnessing, the traditional bulkhead wall, in some way to connect all these ECM plug fans at a single point, and you find a way to make this really easy and to productize it, then the question is that a new type of fan? And at Q-PAC, we believe that it is. The power tool battery is a really good analogy for kind of where our heads are at here. If I asked you guys, is the power tool battery a single device? I think most people would say yes. It is the single device that you use to power your power tool. And when you look inside of one of these power tool batteries, you really see that you could also think of the power tool battery as an array of battery cells that has a battery array cell controller, right? So there's a similar kind of evolution of this type of product to kind of where we're at with our product, right? So the multi-motor plenum fan essentially it takes the simplicity of your traditional blower and motor systems, and it combines that with the inherent redundancy and resiliency of the fan array concept, but without any of the extra complications that come with the fan array. So we're going to get into this a little bit more, show you a little bit of the distinction between those. But the main points for you to understand are that an MPF is a device it's a fan that functions as a single device. So there's one point of power, there's one point of connection for power and control. There's a fan controller in the airstream so that it streamlines the design of the product. You don't have to worry about giving custom wire whips for the connection to the controller. It's going to all be inside that airstream. And then there's going to be resiliency. And you can think about it in terms of resiliency or redundancy, but typically when you think about redundancy, you're talking about providing more of something than is actually needed. So we wanted to kind of move away from the redundancy term and talk about the product or talk about its reliability in terms of its resiliency. So essentially, resiliency with respect to the multi-motor plenum fan is, can it maintain all of the airflow that it's been selected at? So we'll get into selections and the requirements to actually select a Q-PAC product later, but the idea is that if you wanted it to do 50,000 CFM at 3.5 inches of static pressure and you lost a single ECM, you want to still be able to hit that performance point. So you almost build in a little extra room in your fan curve of the fan you've selected so that you can do that. And that is really what people want. They want to maintain their airflow even in the case of failures of the individual motorized impellers. And the last piece here is that they're essentially, it's just like it says in the name of the category. It's a multi-motor plenum fan if there are multiple motors operating in unison with a single input. So it operates as a single device, right? Once the thing is running inside the unit, you have that single point of power and controls that's going to spin these motors at whatever that 0 to 10 speed signal is, and it's going to function as a single device. The ECM plug fans in this case become more like maintenance items. So that is the essence of the multi-motor plenum fan. Single device functionality. So just a little comparison here. That's what these next slides are going to be about. Your single motor fans, your traditional blower and AC motor systems. Um, there's a motor, there's an AC induction motor, and there is a blower. You have to kind of, when you're maintaining and installing this product, you have to kind of make sure that they are working in sync with each other. So you wouldn't really think of a blower and a motor as a single thing, right? There's the motor that has to spin, and it has to be connected via belts or direct drive or whichever way you want to do it to that single blower. So it's easier to think about a single motor fan as really more of a system. You have a blower and you have a motor. With the fan arrays, it kind of depends on how you've set it up, but a lot of times if you have multiple VFDs, um, if you have multiple pieces that have to actually work together to or be controlled separately from one another, then that kind of takes away from the single device functionality piece for it. But the multi-motor plenum fans, they act as a single device. Once it's installed and assembled, you're going to have that single point of power and controls that's going from the fan controller to either the panel board or the exterior control panel, or and the controls point at your BMS to just control it as a single unit. So a lot of times you can think of it as, well, if I took the VFD out and I just ran I ran my power to the multi-motor plenum fan control panel or to the fan controller directly, would I have to change anything? And the answer is no, because it's a single device, right? So it's the idea there. Scope, this is a really big piece, and it kind of ties into both the multi-motor plenum fan as a retrofit product. So as something that you're going to keep an existing air handler and you're going to build out what people would call a custom fan array. In this case, it really is a multi-motor plenum fan because it's more of a like for like swap. You have an existing fan of any sort of technology, and you're going to swap it out with a multi-motor plenum fan that's doing the same performance. For example, someone would say, I've got a 40,000 CFM air handler. It's doing 3.5 inches of static pressure. I need a supply fan for that air handler that does that same performance. And if it was an MPF, you could say, okay, great. I've selected a multi-motor plenum fan that will hit that performance point and fit inside that system. So with the retrofit side, though, that's a little unusual. Most people are used to, okay, if I want to get the redundancy that the customer wants, I need to have I need to go out and buy multiple fan cubes. I have to take those fan cubes. I have to work with a mechanical contractor and a sheet metal contractor to not only assemble the fan cubes inside the space or inside the fan section, but also do some sheet metal around them to make sure that there's a seal, and you can actually establish a pressure differential between the upstream and downstream side of that. Then you're going to have to figure out some kind of control scheme. So are you going to use VFDs? Are these just direct drive plenum fans that need required VFDs? How are you going to control them? Are you going to have one VFD per motor? Are you going to have multiple VFDs? These are all these decisions you have to make and different trades you have to coordinate. So not only will you then have to decide how you want to control them, you're also going to have to figure out I need to have an electrician come and run the power and controls to those motors individually. So there's kind of more scope there, right? And eventually you have someone that has to coordinate uh, multiple different manufacturers. So VFD manufacturer, fan manufacturer, control panel manufacturer, or they're doing those things in house and have to, get all those components and design some themselves. So the scope can really explode with a traditional fan array retrofit project. And with an MPF, it's not the same. You know that when you get one, it's going to have everything you need to provide the multi-motor airflow for that section. It's a similar case on the factory install side. So if this is a component, if it's a fan component going into a new air handler, all that scope is still required. But since you're in a factory setting, people are more willing to kind of take that on, right? And so the nice thing about the MPF, again, is that for air handling manufacturers and consulting engineers and other people that are more concerned with these new air handling unit builds that have this type of product, it really does still reduce a lot of that same scope. It's just the scope is in another place. Instead of being in the field, it's in the factory. And so you get similar value and you get similar and different values from when you look at where it's actually installed. So I think that's the most important piece about the scope here to consider. Speed modulation, essentially, with the MPF, you are just sending that 0 to 10 speed signal, that control directly to the fan controller on the MPF. And with other systems, you have to think a little bit more about it. You have to think, okay, is this 0 to 10 speed signal going to go to each individual VFD? Am I not even going to have one on a traditional belt drive AC motor and blower? Am I just going to give it three-phase power? And I've got the way it was designed is given the belt size and the shiv size, it's just going to do the constant airflow I need. And in those cases too, they're probably relying on dampers to actually control the air volume. So you're going to lose energy there, and it's going to be less efficient. So essentially, it's speed modulation. You're seeing a 0 to 10 speed signal directly to the MPF. Resiliency, back to resiliency, I did discuss this a little before, but the idea is that single motor fans, whether that's a single plenum fan or a single um, kind of squirrel cage blower with belts and your AC motor, those systems are inherently not redundant. They're inherently not resilient if there is a failure. And granted, they do last for a long time. When they were installed 50 years ago, they worked for 50 years before they needed to be replaced. But and there's a lot of this technology out there that is failing, and that's actually kind of how Q-PAC was born. But that's kind of a side note. The point is, if you have a single motor design, then if it fails, you're going to lose airflow. And there's lots of reasons why it's becoming harder and harder to maintain and service those. There's a lack of experienced labor that can service them. There's not as many people out there that are building 6-inch diameter blower shafts for these massive fans in certain places. And there's just facility managers are seeing a large drop in people that are capable of maintenance mechanics that can maintain these things. But anyway, the simple answer is that the single motor fan does not have redundancy. If you lose it, you lose airflow. In a lot of cases, what people would do is they'd actually just have redundant air handlers. So again, it's more than what you need to achieve your goal. And the fan arrays did solve this, right? So when you have multiple fans, if one of them fails, one of these direct drive plenum fans fails, the other ones can ramp up to compensate. But again, if you do lose one of these direct drive plenum fans, it may be a little bit more difficult to replace or to repair. You might have to have a gantry inside the airstream you have to actually, use a chain fall and pull it out with, and that increase in labor, can be cumbersome. So, as again, it's the nice thing about an MPF is that there's much less labor requirement. The product should be designed to be maintained easily, but it still will have the same redundancy or resiliency as we think of it as your fan array, just much easier to maintain. Again, repair and replacement kind of is a similar thing here. I basically covered that, but the idea is that there is a lot less skilled labor. There is less options for you if you have failures of those traditional components than if you just have something using these ECM plug fans as kind of a replaceable component. There's no need to program any to address the MPFs or the ECM plug fans. And additionally, it should be a maintainable product. And that I think is one of the values of our version of it that's coming up here in a minute. But essentially, it's much more difficult to repair and replace individual fan array components or your single motor blowers and plenum fans. Okay, so the Q-PAC fan, this is our version of the MPF. The idea is that we designed this product with the end user in mind. From the fan controller to the interlocking channels to the harnessing to the ledges that the ECM plug fans fit on to the individual plug fan harnesses. Every piece of this product was designed to be easily installed and easily maintained by the end user. There's also a simple controls integration too. So you're going to be able to use your Modbus currently. There's a Modbus connection inside the fan control you can connect to get individual airflow, total airflow, and individual ECM plug fan status too. There will be a BACnet IP version that's going to kind of unlock the rest of the features of the controls inside the fan controller. But that is still several months away. Our team will give you guys some updates whenever that comes out. For this next part of the presentation, I'm just going to shift into some of the features of the product and just tell you guys a little bit more about how this thing works. So there's really 4 components of the Q-PAC fan. There is the fan frame, which consists of these interlocking channels, basically. So when the product is used as a retrofit kit, it's typically going to ship knockdown. So each of these panels is going to stack on each other. There'll be harness bundles on a pallet with it, your hardware box. There'll be another pallet with the control panel if you have that as an option. And then your ECM plug fans will ship on that next pallet. And once the the existing fan and blower are taken out of the unit, then this is just going to install into that cross-sectional area where it was before. So the way it works is once the first panel goes on, there is a bend in that panel that makes this channel with the next piece that slides into it. And once the two flanges there connect, you're just going to shoot your sheet metal screws into the pre-punched holes on the frame to connect them. So it really makes the assembly of the product really easy. You don't need to think about how you want to mount the ECM plug fans. All the holes and the fastener connections are kind of already done for you. There's also riv nuts that are actually around the motorized impeller cutouts. And so when you mount your motorized impeller on the ledge where your harness connections are also going to meet it, you're just going to basically screw in your half-inch bolts to each of the eight mounting locations or nut locations, and then you're going to connect the harness plugs on there as well. So once you've done that for all of those, the installation is really simple. So the next piece are the plug fans themselves, right? Or the motorized impellers. So each ECM plug fan assembly consists of a motorized impeller, an inlet cone, and a mounting frame. Little sneak peek, we are looking at potentially changing that design too, but that's kind of more of an R&D side. The idea though is we have 13 or 14 of these standard ECM plug fan options for the product, for the NPF. The idea is that our product is available over a wide range of performance. We've just kind of designed it that way since our early days, just building custom ECM fan arrays. We can go from 5,000, 4 or 5,000 to 200, 300,000 CFM, depending on the application and the different constraints of that particular project. So we wanted to make sure that there are a lot of different options to maintain a high efficiency and a high FEI, no matter where your performance point lands in the grading of where our selections are available. So that's pretty much it for the plug fans. They are all going to be from the major ECM manufacturers right now. So it's going to be Zeil, Rosenberg, EBM, Pabst, and if you really wanted to get into the details, you could choose which manufacturer. But in general, it's best to just think of it as a maintenance piece. The data and the performance of the product is really all about the multi-motor plenum fan. Actually, that's another piece about what makes a multi-motor plenum fan is that you're going to have empirically derived performance for it as a whole multi-motor plenum fan, not just extrapolated out from each individual ECM. And that's something we're going to achieve with our airflow tunnel, but more on that later. Fan controller. So again, the product is designed for the end user. When we were putting the first fan controller was actually a quick connect box. It was a little dumber and it would just consolidate all power controls. But when we were designing that product, we realized that we don't want people to have to use specialty tools to bend the conductors and bend the conduit to actually run the connections in the field. So we limited it at 95 amps, and that's 9 motors currently. That's just kind of one way. The other features of the fan controller are it's got overcurrent protection for each individual phase of each individual ECM plug fan. There's also the controls, a pretty sophisticated control board inside of that as well. Q-PAC has its own team of electronics and firmware engineers that build that. So it really is the plan is that, it's really going to unlock the future of the product. There's some other R&D pieces in there too that we're pretty excited about. Frame harnesses, this is just kind of what really the piece that connects, the ECM plug fans to the fan controller. And each harness will have a controls conductor, a power conductor, and a pressure tubing, because you can actually get pressure, you can get your airflow values from the fan controller currently. And it's pretty simple. Each one is terminated with Molex connectors, so it really is plug and play. I hate the phrase plug and play. I think it's cliche and it really doesn't describe a lot, but the way this product is designed, it really is quite easy to disconnect and connect the product at the different termination points. So I hate to say it, but it really is plug and play here. Forgive me for that. Performance. This is really a key part about what defines the product. So for a single multi-motor plenum fan, that's 2 to 9 motors, you can achieve an airflow of 4,000 to 90,000 CFM. So that's several orders of magnitude of airflow, and those different orders of magnitude really represent different applications and different physical scenarios, right? A small one, a 4,000 CFM unit might be a small air handling unit that maybe isn't even really considered much of a retrofit project. It seems more like a repair. But as you get to larger and larger performance points, you start to look at, okay, this is a significant piece of a large product that serves my entire building. Maybe that's more significant. So we want to be mindful of that. Um, and that's something you'll learn from working with the product. But something to keep in mind, just if you're looking at applications for the MPF or for the Q-PAC MPF here, the Q-PAC fan, you want to be between 1 and 9 inches of total static pressure and 4,000 to 90,000 CFM. That's per fan. If you're looking at just applications to use us, it's 4,000 CFM and up. Like I said before, you can go past 90,000, you can go up to 300 or 400,000 CFM. It's just, do you have enough room in your Airstream to put enough MPFs to meet that? And that's the situation where you'd work with our custom engineers anyway. But again, this is kind of in reference to our configurator that's on our website. So anybody that wants to, you go to qpac.com. You can actually design your own fan. We'll get into that a little more later, but just for what it's worth, you're looking at a installation window of 28 to 150 inches wide and 25 inches to 140 inches high. So those are your kind of main four constraints for selecting the product. And per the ECM plug fan section in the last slide, um, you do have a 480 volt and a 23208 volt option. Application. So this is a pretty critical part as well. So the Q-PAC fan is designed for comfort cooling. Comfort cooling is when you're cooling people in a building, right? So those are the typical places we're going to see the product. That's commercial buildings, that's office buildings, that's hotels, convention centers. Hotels really not as much, but more hospitals, more institutional places. We're talking lecture halls and universities and theaters. Excuse me. We're also in places like government buildings, lots of maybe courthouses and airport terminals and any space where you're cooling people is really the main application. That being said, the product is due to its high resiliency. It also is really valuable inside of more mission critical spaces. But if you were looking at a mission critical application, it's just going to require a little bit more on the design side. So you'd want to work more closely with a Q-PAC engineer. That being said, that's kind of where the product is applied, but how the product is applied. You can use the product in an upblast configuration, although it is typically just a horizontal airflow situation. And then you also want to be mindful of your clearances and then where you're going to mount the product in the Airstream. So if for example, you wouldn't want to mount the product so close to the cooling coil that you're actually attaching it to the drain pan, right? And we have an application guide on our website that you guys can look through. It's a very detailed document. It's got a lot in there about how you apply the product and can even guide you through your first retrofit if you're interested. So the Q-PAC fan is not intended for corrosive environments. So think natatoriums or pool houses. Typically, there's enough corrosive material in the air that would prevent you from wanting to use the product. That being said, it's all about what the end user needs, especially in a retrofit, really in the retrofit situation. If someone loses a fan and they need to move air for that space immediately, Q-PAC does have quick build options. We have a standard 3 to 4 week lead time, but there's a 2 week, 1 week, and 48-hour quick build option pending production approval. So if you have more questions about actually ordering one or getting more information about how do I have an application I need help with, you can reach out after the presentation. But other places, heavy industrial facilities. So this is those situations where maybe you have 30, 40 inches of static pressure. Maybe this is a mining operation or a wastewater treatment plant where you have some massive fan that has to move air for a really, really high heat load or something like that. Also, wet or high moisture environments like a cooling tower may not be always the best application. But again, whenever you're looking at retrofit applications, at least, you want to be aware of what are the real needs of the customer. Do they need to move air? Do they need reliable airflow? There's always things that come before the recommended application. So just something to be aware of. Specification, per the previous slide in my comments earlier, you really need 5 things. You need a total static pressure, you need a CFM, you need the internal width and internal height of the fan section of where this is going, and you need a supply voltage. So with those 5 points, those 5 pieces of information, you can select a Q-PAC fan. As far as dimensions go, you want to measure the internal width and internal height from wall to wall, and from floor to ceiling. There should not be any offset. You want to measure to about a 1/4 of an inch of you want to measure to about a quarter of an inch accuracy when you're doing these measurements, and you want to take into account things like, does the floor slope? Is there a flange already that's existing for me to mount to? If that's the case, you could always mount to that flange. You just want to add 2 inches to your measurement. And again, this is kind of more of an application piece about when you're inside the unit looking around and trying to figure that out. So if you do have an active application or you want to learn more about fan replacement and access to Q-PAC, reach out after the presentation. I'd be happy to walk you through it. But I want to get to this next point about performance, right? So this shows a single multi-motor plenum fan curve, and it's pointing at a single performance point. So yes, you need a CFM, a total static pressure, an internal width, and an internal height and supply voltage to select the product. But you need to make sure that you understand you're selecting a fan. You're not buying or selecting a performance point. So you really want to identify what your maximum, what your minimum performances are for that system. This is a variable air volume fan, right? So, don't just select a single performance point. Look at a couple different points. If you have access to our internal program quips, which you can also request access to, then you can actually see multiple options for that. And I just encouraging people to be thoughtful when they're making their fan selections. So in addition to the different ECM plug fan options you can get, there are some other additional pieces you're gonna pick out when you're selecting a product. You want to make sure that you've chosen where the fan controller is going to be located on the multi-motor plenum fan. In this case, it's going to be on the left or the right, and you can specify that. Just note that the installation direction is always from left to right, so the location of the fan controller does not affect that. There are 4 controls packages. I'm going to cover controls on the next slide. And then there is an indoor-outdoor rating for the control panel, and then there's an option for backflow prevention, which will be either a blank-off plate or dampers. At Q-PAC, we really discourage the use of dampers unless it is an ultra-critical application. Dampers are going to increase the static pressure of the system. They're going to decrease efficiency, and they're also going to be another maintenance item for you. So we discourage their use. I typically would say if you have a unit that can be down for 10 minutes, then you're not going to need dampers. You'll go turn off, if you have a fan failure, let's say your BMS is telling you that ECM 1 right here has failed, then you're going to see that. You're going to send your tech down to the air handling unit. He turns off the power to the Q-PAC into the unit. He's going to walk in, undo the 3 connections here on the ledge, and then unbolt the 8 bolts and pull it off the wall. All the ECM plug fans are between 40 and 140 pounds, so they should be easily replaceable by no more than 2 people. And you also shouldn't ever need a chain fall either. But again, it takes maybe 10 minutes to swap out one of these in the worst case, and that's from noticing the fan failure to actually completing the swap and turning the unit back on. We used to have actual fan swap races at Q-PAC where we would see how long it took to actually replace one of these ECM plug fans. I think the record is still like under 2 minutes. So it's a very maintainable item. Control panels. So in the previous slide, I mentioned there are 4 controls options, 4 controls packages. There is the Q-PAC fan only option where you're just going to get the multi-motor plenum fan and you're going to run your 3-phase power, likely from a breaker on a panel board, or your own, well, likely from a disconnect that you've provided external to the unit, which is connected to your panel board breaker, and then directly from that disconnect to the fan controller. The controls cable is going to be run from wherever your backnet point is, and you're just sending it a 0 to 10 speed signal to run off of, and you can potentially get your ECM plug fan status, your individual airflow, and your multi-motor plenum fan level airflow from that Modbus connection. The fuse disconnect option is going to be for your, it's just kind of like if you want a Q-PAC fan, but you also want to have a disconnect where you can just run your power to and not have to worry about you trying to use an existing VFD or whatever they have laying around. But it's really just a fuse disconnect in a box. There's a little screen on the front that allows you to verify the switch position, but it really is just a fuse disconnect in a box. It's nothing too crazy. But the more important controls options, and this is what used to be required for a Q-PAC fan. You used to actually have to get a control panel every time because there was no way to actually interface with the fan controller. There was no fan controller before. It was just a dumb box, right? So you had to have a premium or basic control panel. I'm just going to touch on the premium control panel because it has more features than the basic. The basic is a smaller subset of these, but it's going to have a fuse disconnect switch inside of it. It's going to have a handoff auto switch. It's going to have a potentiometer. You can run this in hand mode. So if you're just connecting with the Q-PAC control panel to the fan controller and to your breaker upstream, once all the connection points are made, you can just operate in hand mode. So disconnect switch is on, power is flowing through it, put it in hand mode, and you can modularly change the speed. You can manually change the speed of the product with that potentiometer. In auto mode, you're going to have access to 3 other control modes. So there's going to be a 0 to 10 speed mode where you're going to be just feeding through that same 0 to 10 speed signal that's coming from your building. It's going to go through the control panel, then it's going to go to the fan controller, and it's just going to run off of maybe a static pressure set point that your BMS is controlling. That's probably the most common way we see the product controlled, but we also have 2 other modes for when you have a less sophisticated BMS or no BMS. You're going to have a constant volume mode and a constant static pressure mode. Constant volume allows you to set a specific CFM, and the product will maintain that with the PID loop that's inside of the PLC in the premium control panel. And then the constant static pressure mode does the same thing, except you're maintaining a static pressure that's based off of a PID loop control inside of the PLC. So, excuse me. Those are the main differences. And the final thing is that you're also going to get BACnet MSTP or BACnet IP communication through the Q-PAC Premium Control Panel. And while I believe you can use that to control the product, most people are just using that to get their communications and get their individual ECM plug fan status, their power monitoring information, all those types of things as well. So the fan configurator, I hinted at it earlier, but this is what it looks like in its full glory here. Basically, you're going to put in your CFM, your total static pressure, your internal width and height supply voltage. You're going to choose where you want your fan controller to be located, controls option, whether it's indoor or outdoor, and just hit configure. And it's going to give you the Q-PAC recommended option. So this is a version of our product which has been optimized for efficiency, for long-term value. So this is what's going to give you the highest ROI on your investment over the lifetime of the product. And you're also going to get an MSRP over here. So this kind of tells you what the price is that the end user really could expect to pay. Of course, there are different things about pricing strategy and pricing that you could get into, but that would be something you could just discuss with our team after the call. That being said, it is a super intuitive tool. It's going to give you a submittal as well. There's lots of electrical performance information here, and yeah, it's a really easy tool to kind of get a ballpark of what you're going to be at from a performance and a price perspective. Quips is our more sophisticated internal tool. That's typically for our air handling unit OEMs and our resellers. You go to quips.io, you use your Q-PAC provided login, and you can basically get multiple selections for any performance point you're looking at. So again, back to what I was saying about actually selecting your product, remember you're selecting a fan, you're not buying or selecting a performance point. So look at multiple selections, see what information and what data matches up best for you. If you want to look at performance with an individual with a single ECM plug fan down, you can do that too. It just gives you a lot more flexibility with your design, and it also allows you to optimize on different things like lowest upfront cost, your efficiency, your FEI, your MOCP, your redundancy or resiliency in this case. When you see a percentage value for redundancy or resiliency, what that tells you is that's really kind of code for if you have 100% redundancy, resiliency, or higher, that's going to be the same as having N-1 redundancy with the number of ECM plug fans on the wall. So you lose one ECM plug fan if you have 100% or N-1 redundancy, then the other ones would be able to ramp up to compensate for that and get you to that total performance you selected the product at. Actually, let me go back one slide. The last thing here is that we do have a custom products team at Q-PAC, and you can actually make some slight modifications to the product once you get something that's outside of that QUIP selectable region, which is more than 18 ECM plug fans. That's going to be higher than I think around 120,000 CFM or so. Feel free to call me on that if you have had a different experience. But we do have a custom products team that can help you move the ECM plug fan location. Potentially, you can add a coupler, you can change panel sizes. These are things that are really only necessary if you're not as familiar with working with the product, in my opinion. But it is an option if you have a very exacting customer. So from Quips, you're going to get the following documents: your submittal. So it's going to be 2 pages. There's going to be a ECM plug fan layout, exactly like what you're going to see on the product. You're going to have your performance. You're going to have your fan curve, your sound data, electrical data, all that stuff. to be able to get your quote, which is going to have each line item or each product. So there'll be a supply fan or return fan for each air handler if you'd like. It really depends on the scope of the project. Your assembly diagrams are your assembly drawings are going to show you the order of the panel mounting location, the way the harnesses are going to go on the product. And this is all generated every time you make a selection. So it's not really maybe clear from this particular view, but once you enter in the information for a selection, you get a selection back in less than a minute. So you can really rapidly design the product. And that's something that a lot of consulting engineers and resellers and air handling manufacturers have really enjoyed about using Quips. And that's pretty much it. We also do have DXF files, 2D CAD models for the product. 3D CAD models are available on request. There'll be a step file. We are considering doing Revit models, but that's just not something we have in the product at this point. But that's pretty much it for Quips. If there's anyone that's interested in getting access to Quips, please reach out to me after the call. I can get you set up. I can get you over to our customer success team that's more responsible for onboarding and bringing people into the ecosystem. So there you have it. If you guys want to look at some fan selections, go to qpac.com, click on Design Your Fan. And if you want to learn more about the product, reach out to myself or to James Montgomery. He's my field marketing engineering colleague. And that is what I got. So I'm going to go back to Eddie. I think we may have some questions in the chat, and we can go from there.
No questions in the chat. Feel free to post them in, or feel free to come off of mute. We're happy to hear your voices, see your faces, and we welcome any asks, any conversation. We can even, like Salem said, run through a potential application if you're thinking of a project you already have that you just want to test this out live.
Hi, I have a question.
Sure.
Hey,
And correct me if I'm wrong, I was taking notes as well. You guys mentioned, was it 480 and 208 volt? Do you guys do 575 volt for like other applications needed?
So currently we don't have a 575 volt option. It's something we've looked at, and it's something we may implement at some point. Our engineering team is kind of always trying to select the best ECM plug fans they have in the catalog. But right now, if you do have a 575 volt application, we could potentially help you size a transformer that you would want to have in addition to the Q-PAC fan, but it is not a standard voltage or nominal voltage for the ECM plug fans at this point.
Okay. Thank you.
You're welcome.
yeah, it's a great question, Cody. We actually get that one pretty frequently, so that's a great idea that we might even just put into the slides moving forward.
Cody, are you in Canada?
I am not, but I've worked with some people in Canada, and that seems to be the nominal voltage that. So, yeah, that's just one of the things we get asked a lot too. So.
I got you. Yeah, we've had people just basically get a step up transformer for the 575 volt stuff, but it depends on the size of the project. I mean, that can be cost prohibitive in a certain sense, but I think the value you're going to get from the product is still probably worth it. But just something to be aware of.
And this presentation, if you decide you want to go back, you feel like you missed something or you want to check anything, will also be available on YouTube. I believe this afternoon we'll have it up so you can watch on demand, pass it to a colleague or a friend, maybe your significant other if they really want to learn about fans and what you do. And then we also have great resources at qpac.com. So guides, applications, videos, blogs, the works. It looks like we have a question in the chat. It's not a technical question, but I see it as indeed something that can cut the cost, but yet a lot of places are not using this ECM technology. Why is that?
All right. The reason a lot of people there are some places that are hesitant on ECM technology. I think the main reason is because when the ECM plug fan technology first came out, I can't give an exact date, but as with the first version of anything, they had some performance issues, I believe, when they first arrived on the market. I think most of those issues have been taken care of and solved by this point. We're on the third generation of the ECM plug fans we're utilizing. But a lot of times it is how you're applying the product and what the conditions are from a physical, electrical, mechanical standpoint of when you're using these plug fans. So I think what happens is sometimes people have a bad experience because perhaps it wasn't applied correctly. Again, there were those environmental conditions they didn't expect. And then they'll have ECM plug fan failure, and then they will blame the product and not the environment too. So I think that's my answer for that. Is that what you were expecting, Ali, or do you have a different take on that? All right. Well, feel free to message me afterwards if you want to have a longer conversation. I'd be happy to.
Absolutely. Salem, I don't know if you want to go back to the slide with your contact information, just in case anybody does want to take that. They need to go to another meeting or whatever else they need to do with their Thursday.
Yeah.
We still have time on the meeting, so we're happy to sit here and as questions pop into your mind, whatever it is you're thinking, we've absolutely got the time. And again, we appreciate you sharing yours with us to talk fans on a nice autumn Thursday.
Oh yeah.
I have another question.
Sure.
Great.
The the plug fans, you mentioned EBM, Zeal, and Rosenberg. Do you guys use both composite impellers and aluminum, or do you guys strictly use composite?
We use composite and aluminum. So
Oh,
it
okay.
depends on the ECM plug fan model. If that's something you wanted to select on, you certainly could. There'd just be something to tell us ahead of time.
Okay.
Yeah.
And I have a question. I'm not as familiar with the composite. Is there, and I'm assuming there's certain specifications that where maybe composite can't be used. Do you guys run into that? Or
I see people that have a preference for one over the other, but I think, well, the only one I can think of is there's people that have concerns with like ultraviolet radiation inside the airstream, and they're worried that the composite materials degrade under that. I
uh,
can't say for sure whether or not that's true, but that is sometimes a concern people do have. But I think primarily the reason for the different blade or impeller material is more about generating more static pressure. So again, I could be wrong on that. So, someone fact check me if you want, but that's what I've seen when I look at our fan catalog. A lot of the aluminum impeller options are being used on our higher static pressure
yeah.
systems. So,
Okay. Yeah, I'm not familiar with composite as much, and so that's
mhm,
why I was just curious on that. So
I
Sure.
got you.
And we're sure
And
that if not, your customer might not be as well. And so
yeah.
some, I don't know if we touched on totally, is that we do have a 5-year parts warranty. So we know sometimes someone is transitioning from something like a traditional blower to this technology. And just to assuage those fears and that they can see and trust in their investment, we do have a pretty robust warranty to support you and the customer throughout the process.
Yeah. And Cody, if you want to continue the conversation or you want to chat more, feel free to reach out. You can email me at my address there on the screen, or you can give me a call too. So,
All right, appreciate it.
yeah, you're welcome.
Ollie's got another question. Is it possible to control the fans based on airflow, temperature, static pressure separately and together?
So the way I think that would be done is if you controlled upstream of the product. So if you had a BMS where you have different sensors and things that are feeding into your BMS, you could control it that way. I don't think that would really be um, the controls aren't quite as custom with the Q-PAC product. So if you're using our premium control panel, you're not gonna be able to control on like a superposition of those things. You would either choose airflow or static pressure, but you couldn't do them together. And temperature, we don't have a setting to allow you to control on the temperature of the of the airstream. However, I could imagine a situation where you had a temperature sensor that you had in the airstream, and you could um, likely tie that back into your BMS or into our system, and maybe say maybe like a temperature limit switch or something. But I haven't heard of anyone doing that. So it's an interesting point. But I would yeah, I would actually get our applications team involved in that and our controls team. So we do have a lot of product documentation available on our website and available for me as well, or our customer success team if you would like to get that. And that's going to kind of give you like quick start wiring diagram, our premium control panel manual user guide. That's going to have a lot of controls options and really get into the weeds on what's possible with the control panel. There's also an interlock mode and a fireman's override mode. Really, when we designed the control panel, we tried to mimic a VFD since it kind of looks like a VFD when it's mounted on the wall. But the actual speed modulation and power inversion when it converts from AC to DC to actually control these things is actually in the back of the ECM motor. So that's kind of that. But yeah, um, currently you can't control with a combination of those things, as far as I know.
Salem, would you briefly like to touch on those options that you can use in the premium controller, like constant CFM, constant
Yeah,
set?
yeah. So I did mention them earlier, but essentially there are three real auto control methods that you can use our product for. So there's your 0 to 10 speed mode, which is you're just taking that 0 to 10 speed signal, bringing it in from the BMS, it goes to the control panel, and then that same 0 to 10 speed signal is sent out to the fan controller, which is modulating the speed of all the individual ECMs in parallel with the same signal. Um, and then there is your constant static pressure mode where you can either set this via a backnet communication point, or you can just do it on the HMI on the front of the control panel. You basically just specify a total static pressure for the air handler that it's going to maintain, and it will maintain that as VAV boxes open up and dampers close and those types of things. Or you can actually just tell it to maintain a constant volume of airflow as well. I'd caution against the constant volume just because you don't want to blow out any ductwork, or if there's more dynamics going on with the cooling and heating loads of the building, then you might want to move away from that constant volume mode. But that is essentially the three automatic control modes available with the product.
That's a great question, Ali.
You're welcome.
All right, sorry, I got another question.
Keep them
Not a
coming.
problem.
You guys mentioned backdraft dampers. Do you guys do like inlet guards or anything? Because I know certain builds call for inlet guards as well.
So we used to do inlet guards. We used to do fan cages. We don't do that anymore just because it was just kind of an extra step that added a little bit more to our manufacturing process. And a lot of those things are kind of available externally. You can just buy a fan guard that's
Yeah.
what the size you need, or you could fabricate one on your own.
Yeah.
So we no longer we no longer provide the inlet guards and the fan cages.
Okay.
Yeah. Cody, what is it you do? What type of company do you work for?
I work for a fan manufacturer,
Oh, okay.
but I don't sell EC fans. So,
Gotcha.
Gotcha.
Okay, cool. Yeah,
right.
I'd love to chat more later.
Yeah, I'm obviously familiar with you guys. I spoke with you guys at the AHR show last year. You guys
Oh,
make a really amazing product.
Oh, thank you.
nice.
And we don't do this at all. So I was always curious, and I was like, well, I hope they don't mind because
Oh, not at all.
this is not our forte at all. So
Okay.
um, it is very impressive. I'm not familiar with the controls as much, so I was just kind of diving into that. Our bread
Mhm.
and butter is more obviously the traditional DDPs
Yep.
and forward curves and axial stuff. So this is always you guys have always really intrigued me. I was like, this is really cool. I like the single point connection. It's literally so easy to understand. And I don't have a background in HVAC until I came to this company. And I feel like if I ordered a retrofit, I could connect it. So if I feel like I could do that, I think anybody can.
We
Yeah,
always made
that's
the joke. Go ahead,
go
Salem.
ahead,
Sorry.
Eddie. No, you got
Oh,
it, man.
one of my, as the marketing guy, one of the first things I always tried to sell as a joke was that, anybody in your family could do it, or one WWE wrestler who could lift everything, no problem, right? But like
Yeah.
you could take any two people and in the field absolutely do a retrofit with this, and it be, again, no specialized tools, no specialized labor, and done very quickly, as well as meeting high performance expectations for the engineers involved, the installers involved, but mainly the daily user, the customer, and the people who occupy the building. So um, no,
Yeah, that's exactly what when you guys went through it, I saw you guys last year at Orlando when you guys debuted. It was really cool. And I follow you guys on LinkedIn, and I was like, man, this is something that we don't even touch. We're not going to do anytime soon. Um, yeah, it's something cool to learn about. So
Nice. Yeah,
Nice.
I'd love to connect, Cody. So maybe I'll find you on LinkedIn, shoot you invite or something.
yeah, absolutely.
And if you're
Cool,
coming to
man.
Vegas this year, we've got a stellar booth. We're going to have a kind of a celebration after party afterwards. So hopefully we see for all of you all there, not just Cody, but definitely excited to have you all in the fold.
Yeah, I'll be at Vegas as well, and I'll be attending. So walking around there. So yeah, I'll definitely stop by, guys.
Perfect.
Awesome.
Hopefully, yep, that'll be great. And quickly to touch on a point to circle back to a few minutes ago, you mentioned the dampers at the beginning of that question. One of the reasons, or I don't know if we dove in, we covered so much, but just to circle back to it, that Salem mentioned being able to, if you can run for 10 minutes and it not be an issue, you likely don't need a damper, is that when and if you ever need to replace an ECM plug fan, it truly is those plug and play Molex connectors as well as 8 bolts typically. I think there are a couple designs that have a few more bolts, but I believe it's 8 is our standard. And it truly takes, we timed it at one of our events. You can do it in just 2 minutes if you know how to use a driver and lift a fan into place with the little ledges that actually support the fan, so someone can stand there, or the ECM plug fan, so that someone can stand there and hold it while somebody else drills it into place. It really is such a quick swap. No one would even know that a system was down, or it can run as needed until you eventually get to that replacement. So that's usually for the daily operator side, though.
All right. Well, Eddie, should we wrap things up here? I think we're a little over
Absolutely.
time.
Yep, we appreciate the time. So again, these are the emails. Feel free to reach out to us, watch this on demand, or pass us along on YouTube starting this afternoon. And we appreciate you and hope you have a great weekend. Thanks, everyone.